Welcome students, welcome to a session of ALPHORES e-learning program. In this session we are going to start with a new chapter, new topic that is related to heat. In this topic heat, we will be dealing with a few chapters. First we will study about mechanical thermal properties of matter, and then we study about thermodynamics and kinetic theory, and these are three chapters. And as far as EAMCET examination is concerned, we will be having around 5 to 6 questions from this chapter. So that's why this is very important. And all the basics related to this chapter we are going to study today. So listen very carefully, and I will go sufficiently slow or sufficiently fast as you can understand. Right, now let us start with the topic. First of all, let us know what do you mean by heat. What do you mean by heat? So far as you have studied in physics in the lower classes, you might have come across the words mass and energy. Mass and energy. You might have heard about these two words, mass and energy. Mass we define as quantity of matter contained in the body, and energy is ability of doing work. Ability of doing work is called energy. And try to understand that entire universe manifests in these two forms. Entire universe manifests only in these two forms, either in the form of mass or in the form of energy. That means whatever we see around you, whatever we see, it will be present either in the form of mass. If it is not mass, it must be energy. So these are the two forms of in the entire universe manifests. Out of these two, energy, as we said now, energy is the ability of doing work. And you might have heard about different types of energy like potential energy and kinetic energy. Kinetic energy, we know about these things. Potential energy is the energy possessed by a body because of its position. Suppose you take a stretched elastic rubber band, then it possesses elastic energy. And kinetic energy, this is the energy possessed by a body which because of its motion. When a body is moving with some velocity, it will have some kinetic energy, as we know. And apart from this, we have other forms of energy like electrical energy and sound energy, light energy. All these are different forms of energy, and so also the heat. Our topic, heat. Heat is also a form of energy. Heat is also a form of energy. Now in this chapter, first topic that we are going to discuss is known as thermometry. Thermometry. What is this thermometry? Under this heading, we are going to study about the measurement of temperature. Measurement of temperature. So before going to the measurement of temperature, let us introduce the word temperature. We come across these two words, heat and temperature. We come across these two words. Sometimes these two are misunderstood to be the same. So let us have a clear distinction between heat and temperature. Right. Suppose, let me give an analogy. We said already heat is a form of energy. Right. Heat and temperature. What is this temperature? Now let me explain how to understand what is temperature. Suppose I will take a container. It is having water up to a height like this, and I am taking another identical container where water is present only up to this level. Now clearly here water level is more and here the water level is less. If I ask you where the quantity of water is more, here the quantity of water is more, and level of the water is also more. So practically, because it is a small container, we can say where water is more or where water is less, we can discuss. Suppose there is a very big lake, then how do you measure the water, quantity of water? Only by knowing the level. If the level of water is more, you say more amount of water is there. If level of water is less amount of water is there. So here level of water is a measure of quantity of water contained in the lake or contained in the tank like this or contained in any container. So level of water is a measure of quantity of water. In a similar way, temperature is also a measurement of heat energy contained in a body. Temperature we can understand in so many ways. Let us discuss all those things. But first, primarily understand that temperature is a measurement of quantity of heat contained in a body. When you are talking about a body like this, suppose let us take only one container. Let us take one container. In this container, if I take water level only a very small level, you can say quantity of water is less. When the water level is increased, quantity of water is more. When it is still more increased, quantity is very large. As the level of water is increasing, you can understand that quantity of water is also increasing. So very clearly, quantity of water is directly proportional to the level of water. In a similar way, there is a proportionality between temperature and heat. So if you give more amount of heat energy to a body, temperature will also increase by more amount. That means if you want to increase the temperature of the body, if you supply heat energy, temperature will increase. So for a given body, remember, for a given body, if the temperature is more, you can say it contains more amount of heat. For the same body, if the temperature is less, you can say it contains less amount of heat. So quantity of heat contained in the body is measured by the temperature. Otherwise, we can say temperature can be understood as level of heat energy. Level of heat energy contained in a body, that can be considered as the temperature. So that is the first idea that we should remember about the temperature. Right? I am repeating. Temperature can be understood as level of quantity of heat contained in the body. Level of heat contained in the body. So if the level of heat, that is temperature is more quantity is present. If temperature is less quantity is present. We can understand like this. Now let us move on to another point. This temperature also represents a relative hotness or coldness of a body. Relative hotness or coldness of a body. This is another point related to temperature. What do you mean by relative hotness or coldness? Now, suppose when you are taking a glass of tea which is very hot, when you touch the glass, you feel hot. But same as when you are touching a block of ice, we say it is cold. Then how we can differentiate between them? How to distinguish when you say a body is hot or when you say a body is cold? Practically, when we are touching the body, what is happening is when you feel that hot, the temperature of the body is more than your body. The temperature of that body is more than your body. You know, our body will also have a particular temperature, right? Particular temperature. That is the normal human temperature. So, suppose you are healthy. So you will have a particular temperature around 98.5 Fahrenheit. So now, apart from this, so body is at a higher temperature. When the body is at a higher temperature than our temperature, we feel that body is hot. Whereas, when the body which you are touching is at a temperature less than our temperature, we feel it is cold. That's why if you touch a block of ice, what is happening? the temperature of the block of ice is less than our temperature. So for us, it appears to be cold. Similarly, the other body, the temperature of the hot coffee or tea taken in a tumbler, it is more than our temperature. As a result, it appears to be hot for us. So here, what you are measuring is with respect to you, with respect to our body, we are measuring the temperature. So there is a relative hotness or coldness that can be understood by knowing the temperature of the body. So temperature can be understood as it is the property which gives relative hotness. Relative, remember that always the temperature of a body we are measuring when compared with the other one. When compared with the other one, we are measuring the temperature. So relative hotness or coldness of a body, that can be understood as the temperature. So temperature, we have given 2 points so far. Number 1, temperature represents the level of quantity of heat contained in a body. That is number 1. Number 2, temperature represents relative hotness or coldness of a body. That is second point that we can understand about the temperature. Now let us move on to another point. Now let us consider an example. On a hot summer day, on a table, I have taken few drops of water. I have placed a few drops of water on a hot summer day on a table. After some time, you cannot see any water here. Similarly, otherwise, I will place in a tumbler I have taken small cubes of ice. Small cubes of ice. And I have taken in another tumbler hot tea. I have taken hot tea. I have taken hot tea in a container, and on the same table I have taken ice cubes in another container. Leave them for some time. After some time, if you observe, you will see this is neither cold nor hot. It is neither cold nor hot. And similarly, these ice blocks, they will be completely melting into water, and if you give sufficient time, they will also become neither hot nor cold. That means you don't find any difference in the temperature of the surroundings and the temperature of this previously hot tea or coffee and these ice cubes. Now they are not in the same state. It has cooled down and it is completely converted into water, and temperature of water will also increase to the room temperature. How this is happening? How this is happening? Practically, here the hot coffee, remember both are present on the same table, present at the same temperature, that is under the same room temperature. But practically this is getting cold, this is getting cooled, and this is taking energy. Now how this transfer of energy is taking place here? Because previously when compared with the room temperature, that hot tea or coffee you have taken, it is at a higher temperature. Because it is higher temperature, it is losing heat energy to the surroundings. It is losing heat energy to the surroundings. Then heat is transferred clearly from this hot tea or coffee you have taken to the surroundings. That means the surrounding air particles will take away energy so that this will be getting cooled. Whereas heat energy is taken by ice cubes from the surrounding air particles. From the surrounding air particles, this ice is taking heat energy, and so that from the solid state, that is ice, it is converted into liquid state, that is into the water. So a conversion is taking place from solid state to liquid state, so that the ice becomes water, and after some time, if you give sufficient time, the temperature of water will also increase up to the room temperature. Finally, you will not find any difference in the temperature of this tea or coffee present in this tumbler and ice cubes previously present in this, because both have come to the temperature of the room, or otherwise we say room temperature. Previously, this is at a lower temperature than the room temperature, and this is at a higher temperature than the room temperature. But practically, if you give sufficient time, both are getting cooled to to the same room temperature. That means final temperature is same for both of them. How this is possible? Here heat is lost by the hot coffee or tea you have taken here, hot fluid you have taken, and here heat energy is taken by ice itself from the surroundings. So clearly there is a transfer of heat from this container to the surroundings, and here from the surroundings it is taking heat energy. So clearly there is a transfer of heat energy. How this transfer of energy will take place? Both are present on the same table, at the same time we are placing, under the same room temperature are placing. Why they are not absorbing heat? Both are not absorbing heat and both are not losing heat. Why it is so? Practically what is happening is heat energy always flows from high temperature to low temperature. I hope you understand this. So let me remove that. And heat energy always flow from high temperature to low temperature. High temperature to low temperature. So what is happening when you are considering the hot tea or coffee? It is at a higher temperature than the surroundings. So heat energy is flowing from high temperature to low temperature. And again in the second case, you have taken ice cubes in the second container, but ice cubes are taking energy from the surroundings. So here clearly there is a transfer of energy, but this transfer of energy will always takes place from high temperature to low temperature. Now from this point of view, how can we understand about temperature? How can we understand about temperature, or what we can understand from temperature? Let us suppose there are two bodies A and B. Let us remove that idea, that is coffee or tea or ice. Let us remove that. Let us take two bodies A and B. Now I will keep these two blocks. Let us say A is one block and B is another block. Now I am going to keep them in contact. I am keeping them in contact. Then whether heat flows from A to B or B to A. Whether heat flows from A to B or B to A. Who will decide that? We said previously, heat energy always flows from high temperature to low temperature. So we don't know about the conditions of A and B. Two bodies are put together. So heat energy will flow from A to B or B to A. That is decided by the physical quantity temperature. So if temperature of A is more than B, if temperature of A is more than B, let us say temperature of A is more than temperature of B, then what happens? Heat energy will be flowing from A to B. If temperature of B is more than A, energy will flow from B to A. Energy will flow always from high temperature to low temperature. So here the direction of flow of heat, whether it takes place from A to B or it takes place from B to A, that is decided by the physical quantity temperature. So we can understand temperature in a different way. Temperature is a physical quantity which decides the direction of flow of heat when two bodies are placed in contact like this. It gives the direction, the temperature decides the direction of flow of heat when two bodies are placed in contact like this. So we can understand the temperature in so many ways like this. Now we have a clear distinction between now with respect to heat energy and temperature. Now suppose you take let me give an example so that you can easily understand the relation once again. I have taken water at the room temperature. That means from the tap I have collected some water in a container and it is placed on a stove or a burner which gives heat energy. After some time we can know the water becomes very hot. Now let us see, when it is becoming hot, we know the temperature is increasing. How the temperature is increasing? Here you are supplying heat energy to this, and because of the supply of heat energy, when you are supplying heat energy from the flame, the container is heated, from the container water will take energy and water is also getting heated. So here there is a transfer of energy, but because of transfer of energy, what is the result produced here? Initially water is at the room temperature. Water is present at the room temperature, but now when you heat it, you can see it is very hot. That means the temperature is increased. So how this temperature is increasing? By supplying heat energy. That means the physical quantity responsible for increase of temperature is nothing but heat energy. When you are supplying heat energy, there is temperature is increasing. When you are supplying heat energy here, temperature is increasing. So there is a relation between them such that heat can be understood as the cause, and effect of this heat energy, that is it is the cause, and effect of the heat energy is temperature. The effect of heat energy is the temperature. So what we can understand is heat is the cause, and temperature is the effect of that heat energy. That's why when you are supplying heat energy, the temperature is increasing, and when you are taking away heat energy, temperature will be decreasing. Now in this example, we have seen an increase in temperature. We have taken water present in a container, we are heating it. Otherwise, let us do one thing. I have taken water here, present at the room temperature. I have added some cubes of ice. Ice cubes I have added. After some time you can see the water becomes chilled. Temperature of water will reduce. You can feel water will become cool. Why water is cooled? Initially, as in the previous case, water we have collected from the tap, it is present at the room temperature only. It is present at the room temperature only initially, but now it is not like that. When you place the hand, you can feel it is cold. How it is cold now? Because when you are placing ice cubes, ice cubes are taking away heat energy from the water that is contained in the container. Initially this water is present at the room temperature. From that water, these ice cubes are taking away heat energy and using that heat energy to make themselves melt into water. Initially ice cubes are in the solid state, but after some time when a total ice melts, you can see it is converted into water. So this conversion is taking place by taking away heat energy from the container, or the water present in the container. That means when you are considering the water here, is it losing heat energy or gaining heat energy? Clearly it is losing heat energy, because the heat energy is taken away from this water by ice cubes. So it is losing heat energy. Because of loss of heat energy, temperature of water is decreased. So like this, in the previous example, we have heated water. That means we have supplied heat energy. When you supply heat energy, temperature is increased. And when you are removing heat energy from the water by adding ice, there is a decrease of temperature. So clearly the relation between heat energy and temperature, we can understand that it is simply cause and its effect. Temperature is the effect of heat energy. Temperature is the effect of heat energy. When you are supplying heat energy, temperature is increasing. When you are taking away heat energy, temperature is decreasing. So a relation between these two can be understood as the cause and its effect. Right. Now, let us move on to next point. Regarding heat energy, we said heat is a form of energy. How to measure heat energy? Measurement of heat we will discuss in a separate topic there, but here we should know about the units of heat energy. You know, every physical quantity will be having a unit. Then what is the unit of heat energy? Remember, any form of energy, previously at the beginning we have discussed different forms of energy: potential, kinetic, electrical energy, magnetic energy, or different types of energy you can consider, including heat energy. But any form of energy is measured in the unit joule. Joule is the unit of heat energy in SI system. In SI system, that is Standard International System. Standard International System. In this SI system, the unit of heat energy is joule. Remember, not only heat energy, any form of energy we measure only in the unit of joule in SI system. But remember, exclusively for heat energy, we have another special unit that is used in CGS system as calorie. Calorie is the unit of heat energy in CGS system. In most of the cases, we use this unit calorie also, and joule in generally we use in SI system. So in any of these two we can measure. Calorie is the unit in CGS system, and joule is the unit in SI system. Now, coming to our present topic, in this topic, the first subtopic we are discussing is thermometry. What is thermometry? So far we have understood about what is heat energy and what is temperature and what is the difference between them. So that part we have completed. Now let us move on to the next point, how to measure temperature. How to measure temperature. The measurement of temperature is discussed in this topic called thermometry, and how to measure, right? Now let me continue. In thermometry, we discuss about the measurement of temperature. But how to measure? Now, temperature is not a physical quantity that can be measured directly. I mean, I will give an example. Suppose you are asked to find out length of a body. What we do? We take a scale. Like this, and there will be gradations like this. And to measure the length of the body, suppose you want the length of your pen. Then what we do? We keep the pen at one end of the scale, and at the other end we will take the reading. Suppose this is at a distance 12 centimeter. One end of the pen is at 0, other end is at 12 centimeter. So what we can see is length of the pen is 12 centimeter. It's easy to measure, but it's a direct reading you can take here. But temperature cannot be measured directly. Then how to measure that? Can we understand? Suppose you know when there is a fever and you approach a doctor, they will be measuring the temperature. Sometimes they put a thermometer in your mouth, or sometimes they will be placing a strip on your forehead which gives a reading. So there are so many ways of measuring the temperature. But we should remember that temperature cannot be measured directly. Then how to measure? Temperature can be measured by the effect of temperature. What do you mean by effect of temperature? Because of increase in temperature, there are so many effects produced, and based on that changes or based on that effects which are produced by increase of temperature or decrease of temperature, we can measure the temperature. To give examples, number one, expansion of materials. That is called thermal expansion of materials. We are going to study this thermal expansion of materials after this chapter, after thermometry. But what do you mean by thermal expansion? Whenever you increase the temperature of a body, there will always be an increase in the dimensions of the body. That is called thermal expansion. Solids will expand because of increase in temperature, liquids will expand, gases will also expand. Out of all the three, expansion of solids is least. So generally that is not much used, but expansion of liquids can be used to measure the temperature, expansion of gases can be used to measure the temperature. So one important effect is expansion of materials can be used to measure the temperature. That is one property. Number two, that means with the change of temperature, the material is going to expand. Based on that, we can measure, right? Now, let us discuss about the details of this expansion of materials in the next class, right? Right now, let us close here and we will continue tomorrow. Thank you.